Hey, it's Mr. Thomas here. I'm going to help you get through was this unit 5, lesson 2 in Desmos, the practice problems for it, 7.5.02 as they like to call it. So let's go ahead and get started. It says I'm on the first screen. It says complete each statement with a temperature that makes the statement true. So we just have to put a temperature here that is less than 7 degrees Fahrenheit, in case you forgot how less than and greater than signs work. The alligator always wants to eat the bigger number. So the alligator mouth is pointing toward 7. That means 7 is supposed to be greater. So I could put any number less than 7 in this box. 5. And then let's see here. For the next one, we need a number that is less than -3. So it's got to be negative. And if you think about how the number line on the negative side works, larger negative numbers are actually smaller, right? The further away you get from 0, the more negative you are, the smaller the number. So if you were to put like -2 here, that would be incorrect. -2 is actually greater than -3, so I'm going to go with -5. All right, and then next, we need something less than -0.1. So that's any negative number whose absolute value, as we would say, that's the fancy way of saying distance from 0, is greater than 0.1. So you could have -0.2, you could have -300, right? Anything that's further negative than 0.1. And then lastly, they've switched the signs on us here, so we got to be careful. We need something greater than -2. And so now we need to move to the right on the number line, right? We need to go toward the positive numbers. So if you were to put something like -4 here, this would be incorrect. You need something bigger than -2. So you could do -1, you could do 0, you could do 0, and you could do any positive number. How about 45? All right, determine the value of each expression. All right, so there's multiple different ways of doing this stuff. How about we use a number line this time? I'm going to draw a number line on the screen. We'll go all the way across, kind of a slanted number line, I guess. I guess we'll put 0 right in the middle. -1, -2, -3, -4, -5, -6, 7, 8, 9, 10. That should be good enough, I would hope. I'll label it out. And then we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 over here. All right, and so the first one we have is 5 plus -3. So I'm starting at 5, and I want to add -3. So I need to move 3 spaces then in the negative direction on the number line, right? Going down, going to the left, whatever you like to say. And so I am going to start at 5 and go 1, 2, 3 spaces to the left, and it looks like I get to +2. One mistake that I see students make a lot when they're counting on a number line or when they're counting really anything in math is they count 1 before they actually move. Let me give you an example of what would be incorrect to do here. Let's say I was trying to do that same question, and I started at 5, and then I counted 1 before I moved. 1, 2, 3. I see that mistake all the time. Make sure you don't do that. You have to move 1 before you're allowed to count 1. All right, so the next one is -5 plus 3. So I'm going to start at -5. Actually, you know what's even better? Let's practice doing this as vectors, right? I think in class we probably did vector addition today. So how about this? Instead of starting at -5, let's do it the vector addition way, where we actually start at 0 right? Because we think of this expression as 0 minus 5 plus 3. And then we make a vector that represents the -5. So we travel 5 units to the left and stop at -5. And then from here, we're going to go 3 units to the right. So it's essentially the same thing from this spot on. It's just with vector addition, you model that first number instead of just starting there. And so I'm going to start here, and I'm going to go 3 units right for +3. 1, 2, 3. And so it looks like the answer to this one's going to be -2. Okay, so next I have -5 minus 3. There's not really any good way to do subtraction of vectors on a singular dimension number line. So instead, we always change our subtractions to addition. So that's exactly what I'm going to do. I'm going to change this -3 to adding the additive inverse of that 3, or in other words, it's going to be plus -3. So I'm just going to rewrite it. Instead of this, I'm going to have -5 plus -3. So it's the same thing as -5 minus 3. I'm just thinking of it as addition of -3 instead. And so now to do vector addition, always start at 0. I draw my -5 vector to model that first number. And then I start from there, and I'm adding -3 to it. So I'm going to go 3 more in the negative direction. And it looks like my answer this time is going to be -8. And then the last one says -5 minus -3. So notice that there's 3 like signs that look the same, the 2 negative signs and the minus sign in this question. I care most about the one where I said negative. This is, sorry, minus, the one where I said minus. This is a negative sign. This is a negative sign. The one that I didn't color in green is a minus sign, and that's the one I'm going to change. So I'm going to rewrite this subtraction expression as -5 plus, right? I'm changing that minus to a plus. And then now this -3 has to become its opposite or its additive inverse. So it's -5 plus 3. And look, I don't even have to do this, right? Because we already did -5 plus 3 up here. The answer was -2. So all right, looks good to me. Tracking temperature change is important in many industries, including agriculture, right? If you're a farmer, you got to know if it's going to freeze, you got to protect your crops. It's going to be super hot, maybe you got to do more watering, I don't know. So for each situation, determine the final temperature. The first one says the temperature was 13 degrees and then fell 5 degrees. That's just another way of saying going down or subtract, right? And so that's just 13 minus 5. I think that's pretty easy. That's 8. Okay, the next one, a little bit trickier. It's the temperature was -13 degrees and then fell 5 degrees. What was the final temperature? So I can tell you that a lot of students would get this incorrect and write -8 there. That is not correct. So what we have here is -13 minus 5, right? It fell 5 degrees. Students mess this up all the time because they want to do the 13 minus 5 and they get -8. You can't do that. It's better to think of it as addition and change this -5 to plus -5. And now it becomes a little more clear that, oh, this is -18. Another way to think about it is a vertical number line. Like let's say 0 is way up here and -13 is like here. If you're going to fall 5 more degrees, you should be going -14, -15, -16, -17, -18, right? It doesn't make sense to start going up towards 0 if it's telling you the temperature is falling. So the answer here is going to be -18. All right, and let's move on to the next one. Oh, okay, so it's just more of the same. It says the temperature was negative 13 degrees and then rose 5 degrees. Okay, so rising, going up, adding. So this first one is going to be negative 13 plus 5. If you wanted to think about this on a number line, I like to do vertical number lines when I'm thinking about temperature because it makes me think about like thermometers and stuff. So let's say 0 is like here, negative 13 is here, and we're going to add 5, so we need to go up, right? So this would be negative 12, negative 11, negative 10, negative 9, negative 8, I believe is going to be your answer. I'm kind of trying to circle it there. And the last one's a little different. You have to read it carefully. It says the temperature was negative 13 degrees and then rose to 5 degrees, all the way to positive 5. What was the change in temperature? So there's a few different ways to think about this one. You could think of it as a number line. And so I'm going to put negative 13 way down here. 0 would be like maybe around here. And then this will be positive 5 right here. And now let's just think of it as like two big jumps. Well, you need 13 to get from negative 13 to 0, right? So you're adding 13. And then you need another 5 to go from 0 to 5. So that's a total change of positive 18 or a rise of 18. I don't know if we're supposed to write like the word rise in here, or just putting 18 as our answer is fine. I think I'm just going to put 18 because the fact that I'm putting positive 18 sort of implies that it's going up. Another way you could have thought about this is like, what's the difference between these two numbers they're giving us, right? Like if I asked you what was the change in temperature if it used to be 10 degrees and now it's 8 degrees, you would just say, 10 minus 8 equals 2. You would come to that answer 2 really quickly by subtracting. Well, you can do the same thing here. It's just not as intuitive. 5 minus negative 13. Well, minus a negative is the same as adding a positive. And so this gets you 18, right? I just took the two numbers they gave me and subtracted them. And I could even subtract them the other way. Negative 13 minus 5, well, that's negative 18. And you say, well, that's not the right answer. The answer is positive 18. You're right. That's where absolute values come in. I could write absolute value bars on here to really show what I'm thinking. But honestly, I would just say, I know the temperature went up, so it's positive 18, not negative 18. Like I'm just cutting a corner is what I would say. So screen 5. It says Riku wrote the expression negative 13 minus 5 for this situation on the previous screen. The temperature was negative 13 and fell 5 degrees. Charlie wrote the expression negative 13 plus negative 5. So they're actually both right. In fact, I think I wrote both of these right. I started by saying it's negative 13 minus 5, but that it's better to think of it as negative 13 plus negative 5 because you're more likely to get the right answer. So I would say both are right. And for my reasoning, I would say that falling 5 degrees means to subtract 5 degrees. That's the first expression, right? That's why this one up here works. But then subtracting 5 degrees is the same as adding negative 5 degrees, right? That's Charlie's expression. So they are equivalent expressions and they are both correct. I'll put that on the center of the screen and make it big. If you want to copy mine, you can. All right, let's move on. So I think that's all of the questions in this assignment that are about like adding and subtracting positive and negative numbers. And now the next couple questions are like review of what we did before, which is percents. So it says Imani was assigned to make 64 cookies for the bake sale. If Imani made 25% more than they were assigned, how many cookies were made? Okay, so I like to think of it this way. 25% more, right? 25% more than they were supposed to make means they made the 100% of what they were supposed to make, that's the 64, plus an extra 25%. So they made 125% of what they were supposed to make, and as a decimal, that's 1.25. So if we just do 1.25 times 64, we should be fine. And I know 0.25 is the same as a fourth, so really if I just figure out what a fourth of 64 is in my head, 16, then add that on to 64, I'm pretty sure this answer is going to be 80. And now it says 90% of the cookies Imani made sold. So how many cookies were left? Well, I think the easier way to think about this is instead of thinking of it that 90% sold, that means only 10% were left, right? If you start with 100% of the cookies you had, right, don't worry about the 125% anymore, because now the whole in this situation is all the cookies that Imani made, which is the 80, not the 64. So now 80 is represented by 100%. 90% of those sold, so 10% are left. And that's super easy to figure out. 10% of an amount is just 1/10, or just take the thing and divide it by 10. And I believe that's going to be 8. Oh, so actually now this gets to the explore part. So I'm not exactly sure whether or not Mr. Wong assigned this. I think in my class, I will assign this screen right here. I don't think I want to solve it for you right here in this video because, I don't know, it's fun to think about this stuff. I'll give you some hints though. So I think one easy solution is to make all of the rows, columns, and diagonals add up to 0. And so if I were to do this top row, if I wanted to make it all add up to 0, well, I have a 3 and a 4. If I wanted to add up to 0, I use, sorry, I said 3 and 4, but I meant I have 3 plus 1, which is 4. And so now I just need the additive inverse of 4 in this box to make this whole row add up to 0. So I'm going to put a -4 there. Now, if I want to make this column add up to 0, by the way, you don't have to do this so that they all add up to 0. I just think it's the easiest solution. You can make all the rows, columns, and diagonals add up to whatever number you want, as long as they all add up to that number. I'm pretty sure there are other ways to do it other than making them add up to 0. I just think this is the easiest. So now if you have a -4 here and a +4 here, those already make 0. So it should be pretty obvious what number has to go here so that the whole column still adds up to 0. And once you figure that out, then that should make it pretty obvious what number goes here. And then there should really only be one choice of any number that goes here after that. So figure it out in that order. From here, figure out what number goes here so that the whole column is 0. Then figure out what number must go here so that this diagonal is 0 and also this row is 0. And then it should be pretty obvious what goes in this box last. All right. I'm not going to give you the answers. I think that should pretty much help you solve it though. And then I'm pretty sure in both mine and Mr. Wong's class, the next two, the explore part 2 and Explore Part 3 are both extra credits. So if you want to go for those, good luck. This one's pretty challenging. All right, see ya.